Hello, everyone, and welcome to this new MLIR open meeting. Today, we're going to talk about how to model distinct attributes, with the motivation being LLVM's distinct metadata. And Tobias is going to lead this discussion. Tobias, floor is yours.
Yes, thank you for the introduction. So we will actually have a talk today that starts with LLVM IR and not with MLIR to figure out how we model LLVM IR metadata in MLIR. And as an example, we will actually talk a little bit about inlining. And first we look at the function we want to inline. So it's a simple copy function that takes two pointers and copies from one pointer to the other pointer. And it is annotated with this no alias attribute, which basically means it's a restrict pointer. Then we have a main function that calls the copy function. So that's where we want to inline into. And if we call inline, the inlining path of LLVM, what we get is a main function, again with the inline loaded store and with some alias metadata annotated on the load and the store. And this metadata looks like this, roughly. It's a little bit simplified. So basically what you have is a domain metadata. So this is the name of the old copy function that we have inlined. Then we have two alias scopes, they are called, which basically are associated to the domain. That's the !2 here, but they also have a description, which is copy argument 0 and copy argument 1. And if you follow the pointers here, as we see, for example, the !4 is in the alias scope set or list 1, and this is used here. So the 1 is basically the second argument, or the argument 1, and the store aliases with this second argument. Now the details of this are not super important. What is relevant for the talk today is that we have like two kinds of metadata nodes. The first one is the unique metadata nodes. So this !0 and 1, these two nodes, they are similar to attributes in the sense that if you have two nodes that have the same data, so twice !3, for example, it will be unique into one node and you have just one thing. And there is also distinct metadata, and the distinct metadata is not unique. That means it is, if you have two nodes with exactly the same data, they will not be combined to one node. Instead, will have two nodes. So as an example, if we inline the copy function twice, we will have two domain nodes. Both domains nodes will have the same copy data in them, so they're exactly the same, but because they are marked distinct, they basically map to two metadata nodes with different tags, so !4 and !5. So that's basically what we want to model when we import or export from or to LLVM IR. Yeah, if there are questions, please. If something is unclear or I went too faster, so please interrupt me. So what do we need to consider when we want to model metadata in MLIR? This may be a bit the biased view. So just considering the stuff that I've seen recently, so there may be other concerns here. But one thing is definitely that metadata is a module level information. There are distinct and unique nodes. It's also somewhat structured data. So in LLVM IR, it's not super structured, but still it consists of usually nested. It's like a nested tree that maps fairly well in MLIR to something like structured attributes. Yeah, we have different kinds that we model currently. So we have alias metadata, access group metadata, loop metadata, and debug metadata in MLIR. There are also other kinds of metadata that we don't have yet, so such as range metadata, for example. And one thing that is special in MLIR is that we have parallelism. That means if we have a function path, we want to be able to manipulate metadata in parallel. And we would like to avoid that we have to do everything sequentially. So we sort of want that the metadata creation is thread safe, and it should also be deterministic in the sense that when we run the compiler multiple times, we always get the same result. Of course, what we could do now is say, okay, in LLVM dialect, we do everything sequentially, but there are things like, for example, inlining, that you cannot do sequentially. So basically, the framework forces us to do it in parallel. And also, it would be very interesting when we lower from higher level dialects that we can do stuff in parallel. I see there is a question in the chat or comment. Yeah, okay.
No,
Yes.
that was just a comment while you were explaining LLVM, and something that the distinct node allows in LLVM is indeed not to make it only a tree, but make it a DAG of relationship between the metadata. That was just while you were explaining, nothing important.
Yeah, that's it. So my conclusion when I look at this sort of requirements is that attributes are actually a good match, except for the distinctness. So that's something you can that's really hard to model with attributes. Currently, there is already a representation of this alias scope metadata in MLIR. So what we do for this is we have a global metadata op that is stored in the module. And this metadata op contains metadata operations, which carry the relevant information. So you see here again the copy and copy argument, and we have a scope and an alias scope. The idea here is that we connect these things using symbols. And we also use a symbol in the actual code to reference the metadata. So this is only one way of representing metadata. We also have debug metadata and loop metadata, and this is already expressed using attributes. So we have like currently two ways of modeling metadata in LLVM dialect. What is now the limitation of this op-based representation? Essentially, it forces us to create new metadata operations sequentially. So we would always have to use a module level path without parallelism if we want to create such alias operations, which is hard in inlining because the inliner is always parallel, and except you maybe, well, I think there is no real way to enforce sequential execution of the inlining. There is also, that's more like a cosmetic thing. Because of the simple references we basically need to introduce verifiers that check that a specific symbol always points to the right kind of metadata. If you compare this to the implementation of the debug metadata, the debug metadata is a bit nicer because it's basically composed struct attributes, and their table gen basically generates all these verifiers. So that's just one other slight disadvantage. Now, we thought of multiple ways how to solve this, actually of two relevant ones, and I would like to show you what ideas we had. So the first one was that we basically, okay, an attribute cannot be distinct, so it's always unique. So what can we do to make them distinct? Well, we can add like a unique identifier to every instance of a new attribute to avoid uniquing. And now the question is, well, how do we get such identifiers? And one way to do that would be a mutable attribute that allows us to generate identifiers in a thread-safe way. Plus, because of the non-determinism issue, to avoid non-determinism, we could generate identifiers on a pair function level. So this is now very abstract. Let me give you an example. So the mutable attribute that generates us a sequence of unique identifier could look like this. So we call it here distinct sequence. It has a scope, so that is basically the function for which it can be used to generate identifiers. And it has a mutable state. So the state here is 2, but this is mutable, basically. And the attributes themselves would then have some extra elements or members in the attribute, which is a unique identifier. And we would also reference the sequence that generated the identifier in the attribute. So with this construction, we can basically, well, okay, plus we also have the actual data, which is here then just to copy again as in the previous example. So now this may still be a bit confusing. So let's have a look how this looks like in the code. So in the code, when let's say we're in the inliner and we want to generate a new alias scope or domain attribute. What we would do is we would first get the distinct sequence for the function we are in. So we call this distinct sequence attribute with the function name as a parameter. And this will now, what this will do is will create the attribute. It will go to the storage uniquer. And if the attribute is not yet there, it will create a new attribute which has the state set to 0. If the attribute is already in the uniquer, so if we have generated an ID before, we will get the attribute with the state to set to the last value. So whatever is in the storage uniquer, basically. And then we can create a new such domain attribute where we call distinct sequence get next ID. So this will now mutate this sequence. So it will increment the state and it will return the current identifier or the next identifier. So if this was 0 before, so if there was no sequence found in the storage uniquer, it will basically just return 0 and increment the state to 1. If the state is 2, like in the example I showed you before, it will return 2 and increment the 2 to 3, basically. And here, this is the distinct sequence we had in the example before. So if I briefly go back, no, sorry for that. So we have the ID and basically the sequence, and that's what we pass in here, ID and sequence. So I tried to come up with pros and cons for this solution, and I think the pro is the relatively low implementation complexity to what I will show afterward. The cons is that it is a very LLVM dialect specific solution. It also leaks implementation details in the sense that we wouldn't like to know that such a sequence even exists when we look at the code. And it also has unintuitive behavior if we, let's say, use an alias or an attribute that we created in a specific function and then we copy it to another function, then it's sort of unintuitive because we may have attributes in the function that reference back to another function. It also doesn't require core infrastructure changes, so this would be possible with the current MLIR core infrastructure. Then the second solution, and sort of my favorite solution, I guess, so far, is that we add support for distinct attributes to MLIR core. The idea there would be to update the storage uniquer so that it supports distinct attributes, which we would mark with a trait. So we would put a trait on attributes that say it's distinct. And if the storage uniquer sees such an attribute, instead of looking for an already allocated attribute, it will always allocate a new one if you ask for a new attribute. And what that means semantically is that instead of having an identifier stored on the distinct attribute that avoids that it is unique to the same attribute, basically, we sort of use the pointer value as this identifier. And during parsing, or mainly during printing, we will actually walk all the distinct attributes and give them or print an identifier for this attribute. Doing this during the printing is actually nice because that makes the IR deterministic, in the sense that the numbering will always be the same based on the program order. So how could this look like? This is so in the roughly what it looks like in the prototype I did some time ago. So basically, we still have the attribute printed here as a normal attribute, and there is a wrapper around it that says that this specific attribute is distinct. And we also have a number here that is sort of the unique identifier. It's not stored on the attribute itself, it's really generated during printing. Yeah, exactly. That's what I wanted to say here. And one more important point here, this attributes actually compose with attributes. So we can have a struct attribute that contains this alias domain. One nice thing is that such a feature can quite easily be supported from TableGen. The only thing we need is to mark it with a trait that says this attribute is distinct. Otherwise, it looks like any other TableGen generated attribute. Where the changes are actually in the storage uniquer. So the storage uniquer, usually when it gets an attribute, it has an is-equal method implemented based on the hash of the attribute, or of the key of the attribute, basically. So if it gets two attributes, it compares them using a key, and we can overload or change this method to return false for a distinct attribute. Now this would be sort of suboptimal. So we also in the prototype we have an atomic counter in the context that basically produces a new integer value for every distinct attribute we get to avoid hash table collisions. Now, what it means semantically is if in your code you have this distinct attribute and you call twice get with the same value, if this would be a normal attribute, utter1 and utter2 would be the same pointer. But now that we mark this as distinct, utter1 and utter2 will actually be different pointers. So we allocate a new attribute every time we call get. And yeah, exactly. So during printing and parsing, we basically walk these attributes in a specific order, and while walking, we have also a counter that is incremented and printed together with the attribute. The cool thing is also that this can be composed either with another distinct attribute or a non-distinct attribute. That doesn't matter actually. So here we see that domain 1 is used in scope 1. And the scope 1 is then used to annotate the load, for example. We can also, so this format is, here we print basically aliases. That's now super confusing. It has nothing to do with alias analysis. It's basically this names that MLIR can print for attributes at the beginning of the module. but you can also print the attribute inline. It would then look roughly as follows. So basically, you still have a numbering from out to inners attributes, and it would be simply print inline. So the pros of this solution is that it is storage efficient, because we don't need to store this. Well, I mean, it's a small thing, but we don't need to store an ID and a reference to a sequence. It's also quite a concise representation that does not leak any implementation details. It's also a generic solution that is not necessarily limited to the LLVM dialect, and TableGen works out of the box. I think its disadvantage is mainly that it is more complicated to implement and requires more changes. So basically, I said at the beginning, we need thread safety. So I think both solutions fully rely on attribute. That means attributes per se are thread safe, mutation is thread safe, and attributes also have a global scope, which matches quite well how LLVM metadata is modeled. So both solutions are thread safe thanks to attributes. Determinism is handled a bit different in these two cases. So parallel processing is non-deterministic by nature. So you need like some other trick to get determinism. In solution one, where we had this sequence attribute, that the trick is that we scope the identifier generation to the function, and we assume the parallelism is only across functions, but not inside the function. And in solution two, we generate basically the identifiers during printing and use the position in the IR to generate the identifiers. That's another trick how you can avoid the parallelism, basically. I have also a sort of a short slide on maybe using properties, but I don't have a solution there, so rather questions. But maybe we actually want to use this in the discussion afterwards. But what we're unsure about, how we could ensure composability of attributes with other attributes, of properties with other attributes, and how we could actually implement the printing so that identifiers are printed on program order. And yeah, what would be nice is also having a way to print aliases at the beginning or at the end of the module somehow. So yeah, I think these are basically my points, and for the discussion, I sort of put the requirements as a reminder, basically, for the discussion. See, there are some comments, but I actually need to go back and read them next. But yeah, questions or comments, or this is my last slide.
Thank you, Tobias, for the presentation. It was great that you took it from first principle and explained the problem and the LLVM model. I think that was helpful to contextualize for everyone. Yeah, we're going to start with questions. Feel free to raise your hand in Zoom, or unmute yourself if you want to ask a question. I'm going to get started with a quick one. I'm wondering about your printing. If you can go back to a slide where you show how you want to print this, and you said you're going to have a unique ID that is computed by the printer. So I assume it's kind of the same mechanism as the SSA values.
Yes.
That's going to do numbering. Something I'm wondering is that now you need to traverse not only the IR itself, but you also need to traverse the attribute hierarchy to find all the referenced unique attributes by other attributes as well, but also by properties, for example, because properties can reference attributes, and that's not introspectable generically. So there's no generic way to guarantee that you're going to visit every possible attribute, I believe. So that's a wrinkle. And also I'm wondering about the scoping of those ID, the 0, 1, 2, because that means now if I copy paste IR somewhere else, I'm responsible for renumbering, I think. There's no clear scope associated to those. They are global, I think.
They are global, yes. I mean, I think there was, Alex actually pointed me at the discussion that happened quite a while back on scoping. So I think the idea was to have different scopes, basically, I think for attributes as well, so that you could have attributes with a module scope, with a function scope. Yeah.
The idea was to have these aliases that we have scoped to a module instead of being a supra-module thing that they are right now, but that has never been implemented.
Yeah.
But yeah, copy pasting, like it is not clear to me why do we need these numbers as opposed to just having these aliases listed. So like create a distinct and create another distinct and just refer to them by the name. I suppose it's related to like the inline syntax.
Yeah, exactly. So, I mean, okay, we wouldn't need this if we could say we always have, it's always guaranteed to have an alias, basically, a global alias. Then we wouldn't need these numbers. That's true. But I think, I'm not sure if this is possible, actually, that we enforce that a specific attribute is always printed with an alias. Because indeed, that would make things much easier, right? Because then you would already have by nature, then you would have already a number, namely in this domain one. It's not in real MLIR, it's numbered domain and domain one. But yeah, I'm not sure if this is doable. That would simplify things, I think.
I think we can, because we currently do it, for example, for location, where we print the aliases after we print the IR.
The problem is that right now we forcefully don't print aliases when we do local scope, but realistically that's more historical in the fact that aliases were never load bearing in a useful way. Because I also kind of share some concerns about using the numbering scheme, both in terms of the complexity it adds and some of the problems with copy paste. So the requirement that aliases aren't printed in local scope isn't a hard requirement, really. I mean, that's just essentially how I did it years ago. So, I mean, if that makes infrastructure like this easier, then we can always realistically reconsider that.
Also, I think that would be nice, yeah.
The aliasing question would also solve the other thing I reported, where you cannot really introspect everything. If we print aliases after the fact, that means during printing, we know, like the printer knows it just printed a distinct attribute, and so you can record those and create alias on the fly and print this later. I would still look into something as scoping, like try to implement something, as Alex mentioned, where we would need a mechanism to decide. Like, well, I mean, it'd be great if we're not like collecting everything and printing all the alias at the end of the file, but we had a way to scope those.
We can already do that technically, because the way that the printer works is that it does like a fake print first. So it fake prints everything to collect aliases before you even do the real print. So conceptually, we would already be able to capture which things are going to be printed, because we fake it first to collect the aliases, and then we do the actual printing. So that should already be fine.
So how would that work in practice? So you would also add, for example, a trait on an attribute that says print with module scope, and then the printer would just collect the ones that have this trait separately and print them inside the module, or?
I mean, you don't have to do, it can be a global alias. It doesn't have to be inside of the thing. The only characteristic of these aliases would be that, well, we would have to redecide how we handle aliases in terms of local scope. if it's something specific to these types of attributes or types, I would assume as well, conceptually, then we would have to have some marker indicating it, which could be specific to distinct things, but we could also expand it to locations if we wanted as well, if we found that interesting. And then we would have to tag it somewhere like that, which could be the dialect's responsibility, but that's kind of sketchy with distinct stuff, or some other way. But
I think in the LLVM dialect, the global scope is only a problem if you would have multiple modules in the same file, basically. Is this
which we
even
do have on the
possible
target GPUs?
on the GPU side? Okay.
So we
But
can
even-
have an LLVM module with another LLVM module inside, and we compile the nested module to get the binary blobs that we feed to the outer module to compile on GPU.
Yeah, but even then it's probably still working because the metadata is mostly immutable, right? So it's not really problematic, probably for the, at least for the aliasing and debug info, etc. Well, maybe debug is problematic. I don't know. Yeah, see, Bruno raises his hand. Go ahead.
Hi, Tobias. This is pretty cool. We want to use that in LLVM, so keeping an eye on stuff. I have two questions. The first one is, at any point did you consider, while creating designing the metadata stuff, the distinct metadata stuff, just attaching MLIR location for trying to distinct between the attributes? That's question one. Question two is, have you ever give some thought about like changing that in LLVM so that we don't have to change that in MLIR?
So changing LLVM is probably, so I guess there are reasons for this kind of distinct nodes in LLVM. It's indeed not always clear to me what the exact reason is, but I think it also has to do with, so one thing I read, it has to do with converting to bitcode somehow. But I guess also for in certain cases, you really want to have the same data in different nodes.
I think one of the reasons you really want to encode distinctness, and one of the things like we're discussing alias analysis results. And if we were to store alias analysis results, we need to identify that two pointers originate at different allocations. We don't actually care what the allocations are. We just care that they're different. And that's the thing that we would like to model. Hence why I was pushing you into like, let's model distinctness, because now we only need it in LLVM just because nobody did aliasing analysis in MLIR properly. And when they do, and they want to store that, they would need that exact thing. I want to say two things are different, but I don't care how exactly they are different.
Yeah, so yeah, exactly. So that's the, let me see if I can go back to the example in, it is a very short, brief example, so maybe, yeah, okay, this is not so good. Actually, access groups would be nicer for this because they're really empty nodes. That's another concept that we would like to model, and I don't have it on the slides, unfortunately. But there you really just have empty nodes, and the only meaning is the tag, basically, in LLVM. Well, and relying on locations sounds, I don't know, it sounds a bit hacky. So what if you use the same distinct node from the same location for some reason? I think it really makes sense to have a something.
No, the worst case scenario, everything is contracted with unknown lock.
Exactly. That is everywhere. Yeah.
Yeah, that makes total sense. I'm just in general curious, like, what what were the other attempts you've met like through the path? Thank you.
By the way, for those who don't know, location is stored as an attribute. It's just not part of the dictionary, but location is just an extra attribute that can be emitted on the operation, with restriction because it's a location attribute, but behind the scene is the same thing as an attribute. If there are no more questions, I have some ergonomic constraint or question, which is like you showed an example where we do get and then get and we get twice the same. To me, it seems that I understand the convenience of reusing the existing table generation and all the infrastructure. If we do something distinct, that's to me different enough of a concept that the API should probably reflect it. Like we shouldn't read get here. We should probably, get distinct.
I mean, that can be done. So we can have a get distinct or something like this.
Yeah. You can do enable if on a trait that has the exact same comment.
Exactly.
Yes.
This is a minor comment, but that was just saying. Other question
that makes sense.
Is
Sorry.
one of my other minor concern is we're opening this. I mean, if we're opening this, we offer the possibility of non-trivial leak in the context, meaning people can store any kind of data on those and abuse the distinct attribute because this is a good reach. But we don't have a way to garbage collect or deallocate any of these right now.
So I would argue that this is already possible now. If you want to, you just add a counter to your attribute. But
there is a difference between people can get around the system and the system is like encouraging it as a first-class concept, right? You see what I mean?
Yeah. The best thing you can probably like document that and review. I don't think we have a technical solution of like against abuse. We have this thing called integer set, which is even worse than this. It may or may not be unique depending on its size. And since it's a matrix, we can store arbitrary binary data in there. So maybe we should actually, like you mentioned, garbage collect. Maybe we should somehow have a garbage, not really garbage collect, but sort of compaction of context of saying, here's the context, here are the modules that are currently using the context. Go and drop all the context objects that are not referenced by this module. Which could be helpful on its own, like after transforms, we might want to do that anyway.
This is possible because we can walk the attributes, or?
You cannot walk the attributes, but you can walk the module and see, like you can walk all the operations in a module and have a set of all attributes that are referenced by a module.
Mm-hmm.
But there is no back reference. So there is no reference counting or any other mechanism that lets the context know that something is referenced. It's only the user of the context that should know, oh, I created these modules in this context. So everything that can reference the context must be contained in these modules.
I remind you, Alex, because you said we can walk the module and get everything that is referenced. With properties, you cannot do that generically.
It's also not really a guarantee because dialects can store references to attributes and types inside of themselves and in sideband data. So you can't definitively know given a single operation module. Then the user would also have to know that any passes that they have active should be rebuilt from scratch because passes often also have references to stuff.
Okay.
Yeah, otherwise, yeah, reference counting.
I didn't mean to dog on you, Alex.
Yeah,
It's
no,
just
I'm just
yeah,
like
sorry.
I'm trying to figure it out. It's a good remark that like dialects. Okay, we can live with dialects and like have a dialect interface that says if you do store something, please provide an interface telling what exactly you store. But properties and passes are more, especially properties, I think, are more difficult to handle. So unless we actually do reference, which is unclear to me if we want to do reference counting, because we might want things to keep existing in a context, because we might like, it really needs to be an explicit act of garbage collecting the context, not something that happens in the background, I think.
Yes, it's also something that I wouldn't inherently have as a blocker for this, especially because it's something discussed at length. And with properties now, I can see the guidance situation being significantly different in terms of what we encourage. I almost wonder if we could, like, if we had a trait for distinctness, add requirements in terms of what you use it with, realistically. But if we can limit it from the beginning, but I don't know if it's necessarily possible given the use cases you have.
You mean limit the number of the size of such a distinct attribute or the number of allocations? I think the size is always small for these LLVM examples I have in mind, although debug metadata maybe not. So in debug we may get.
I think it gets tricky because like on the slide, on the example, you have a string that you store in that attribute. Mm-hmm. And a string can be arbitrarily long.
That's true.
In the general case, so like, and you already have the use case for a string, so it is like, it would be nice to say, well, we only have empty distinct things, like we will basically need only one.
Although the string is actually, if it's the same, it's also an attribute, right? I think.
So can we maybe think about having a distinct attribute that only serves the purpose of being distinct, and then having another attribute that contains a distinct attribute plus some data. And that data is unique because it's an attribute. And we only have like distinctness bit, and we don't actually store anything in the distinct attribute.
Oh.
I think that would be possible. It's a bit less nice in terms of composing things, because this way I can use this domain directly inside the scope, and it's basically type checked. So I can have another distinct attribute that is an alias scope attribute, and that has actually an alias domain member or parameter.
That should be fine though, because the alias domain attribute would just have the distinct one as a parameter. Or it even could be an implicit parameter based on a trait, realistically, or something.
Sorry, I thought, it is composition. So yes.
Alex,
yeah, go ahead, maybe.
Is what you're getting at almost is that it's almost as if any distinct attribute can just be an indirection to another attribute, just one step in the hierarchy. It's like to say the only thing that a unique attribute can contain is a dictionary of other attributes, conceptually.
Yeah, that's maybe another way to.
That would make them single pointer always. That would be something we could consider, yeah.
Yeah, that sounds interesting. I think that could work.
Or like another way to say it would be, the only thing we could make unique would be dictionary attribute. It would be a unique dictionary attribute, and that's the only thing we expose. We can always create a distinct dictionary attribute. Sorry, I said unique. I think distinct dictionary attribute, but that's the only thing you can create. And that returns you a dictionary attribute plus the distinctness property of it. which is implemented exactly as like your distinct things that as only parameter the dictionary attribute that will be created for you. That would probably match well with the uniqueness the system.
I mean, reusing the dictionary attribute or having a different dictionary attribute?
I was just saying, like, conceptually, you call this concept distinct dictionary attributes, and I'm just calling out a concept here. And what would you reuse is that the dictionary attributes, the existing dictionary attributes, would be exactly as let parameter equal here.
Yeah, just that it's not extensible at all. So you don't you're not allowed to create your own distinct attributes. You just have that, and the actual attribute that is being made distinct as like a first-class concept in the IR, which contains a dict utter inside it.
Yeah, and it provides
it's extra indirection, but that's all.
Yeah, it provides the numbering and the scoping capability, basically. That would be fairly nicely orthogonal to have this, I think. I don't think we need to restrict it to dictionary attribute. It could be for wrapping any attribute.
Yes, so ideally we could just add it as a parameter here, right, in this example. So instead of changing the alias domain with this distinct trait, which could just have here a distinct ID or something in it. And this would probably, yeah, so this would be sort of be built in, I guess, then. So users would not be able to have or to construct their own distinct attributes. They would just use this to make them distinct. Yeah.
I had another question. At some point you were mentioning that like the storage uniquer, you would still use the storage uniquer for storage. And I was wondering why to some extent.
So I found actually an old commit, well, not so old, that was exactly about these integer sets. So it seems like, and the commit message said that they benefit, so they basically the commit changed the code to always put these integer sets in the uniquer. And the reason was that performance was apparently much better, I think, because the storage uniquer is quite a beast in terms of sharding and allocating stuff in a very efficient way. So I think if I try to implement this, so I need to think about this new idea because it may change things. I'm not sure, but I guess the nice thing with using the uniquer is that it's the performance we get.
Yeah, but it's performance for uniquing. What puzzles me is that if we don't need any uniquing, it's just like, it's like, why can it be a vector of
but I think it's still trying to allocate close to the core where you create the attribute. So I think River knows much better, but I think it does more things than just
well, there is some sharding done for threading.
Yes.
The threading aspect is about you of locking in many cases. That might be the thing you benefit from. Yeah, that might be the shards of allocator that can be useful more than the uniquing mechanism.
I mean, integer set is unique in the fact that it has data, like actual data inside of it, which is a little bit different. I mean, I would honestly be surprised if the performance benefits there from the uniquer itself, because that's trying really hard to recover performance, not necessarily grant new performance, because it should always be faster to do it directly, like inline. That's just inherently going to be faster. So the uniquer is not magical in that regard. The only thing I could see is it would gain performance in terms of actually uniquing the things, which the decision made to not unique them many years ago probably necessarily didn't hold up, depending on the use cases that it was being put under. That would be my assumption in terms of performance there. but it's not like using the unique here should not be used for performance because it's going to be slower than straight line code that's allocating. And it also is never goes away.
So we can, so we can just use any other thing. I don't know, a vector, and get new addresses from this vector, basically.
I guess one thing is like you could use a parameter that's not even an attribute. That's just a struct whose equality always turns false. Like, I guess that wasn't really considered. You don't need an attribute that is guaranteed distinct. Like you could model that with the non-attribute parameter to your attributes stuff.
So I'm not sure. So I can have non-attribute parameter. Aha, an integer, right? I can have an integer actually.
I mean, the parameters, the string headers and quotations, you put whatever you want in there, technically.
Yeah. So in the end, I can have an atomic counter for distinctness in the context.
Technically.
Oh no, because of the that would then we are back to the non-determinism problem, I think. So we still need the deterministic way of generating aliases, I think.
The problem is printing. It's textual.
Yeah.
Mehdi, you were going to say something?
Yeah, no, I didn't quite get how you get a global counter from using this trick. You still need a global counter, maybe you were saying?
I don't think you need a global counter at all. Like, what's the global counter used for?
Like, what do you do with your integer in the parameter list?
I mean, I wasn't saying an integer. I was saying like an empty struct or something. Like if there's two different things. You have to guarantee uniqueness on creation, which just really boils down to the equality function returning false somehow. And then you have to guarantee uniqueness or distinctness in terms of the textual format, because I don't think the bytecode would be problematic because that handles it correctly. The textual format is the only one that really needs to guarantee that multiple references to a distinct thing like get remapped correctly. But that's an alias problem as opposed to like a representational problem of what is stored in the attribute. So I don't think you would need a global counter or anything on construction. All of this stuff boils down to what you do in the printer, which if you always had aliases or a way to guarantee them, even in local scope, you could, like, you don't need a counter at all. Or at least I don't see the situation where you need one.
So So as far as I understand, so by empty struct you mean you just do a malloc of an empty struct to get an address there.
I mean, I wasn't even saying that. Like the operator equals could return false. Like,
okay.
There's nothing that you really need to do, like in terms of allocating. Well, I guess there's some questions in terms like the uniqueness in terms of the equality function is only used on uniquing, not on comparing attribute instances.
Yeah, so that's what I've been doing now, right? So I basically, if I see this trait, I basically change the isEqual function in the storage uniquer.
Yeah. So in terms of the like being able to do this today, the only thing that I see fundamentally holding things back is the textual format, realistically.
I mean, there's a discussion of how we would actually want to model the distinctness bit in terms of the attribute definitions, but I think the inherent problem of the textual format remains regardless of the implementation on that side. And that's the true crux of the issue, because there's hacky ways to do it now on the attribute definition side, but there's nothing to do it in terms of the textual format.
So I think that the idea we had before, that we always print them, the alias basically, wouldn't that solve the textual format problem? Or you mean that? Yeah.
Yes. I mean, if we can guarantee that aliases get printed, then yeah, that handles it, basically.
River, I have a question that for you maybe here, which is, what about resources? Like today, isn't like resources a way to always have aliases like that? Where you have a reference to an attribute that is kind of distinct also, but with a handle that doesn't have a name and the name is computed by the printer?
Yeah, I mean, that's effectively the storing the bit on the dialect. So in that sense, the dialect maintains the keys, so it guarantees distinctness that way because you kind of have to have a unique name, really. So I guess the question is really in terms of, so I guess there's like two ways. You could do it with resources where it just points to basically nothing. I think that would be the only real question is in terms of, it's like an empty resource, basically. Which you could do that to get it. And actually you could probably do that now.
Yeah, I was thinking
get the
like with
distinctness.
resources. Like, can't you even point to other attributes? Or maybe you cannot point to other attributes in your resource though.
That gets a little not really sketchy. You can technically. I mean, a resource doesn't have fundamental limitation.
So how are the
Actually,
names
it does.
generated for resources? Because I looked at it and I didn't. So for me, it looked like the name is generated manually somehow for every resource. Is that wrong? Is there an automatic naming? Okay.
Yeah.
Depending on what you do, I mean, you have freedom to do it yourself. There's a blob manager that does some renaming automatically. I think.
So can't we implement already like what's needed here with resources? What would be missing?
I don't think anything actually, because if it's a handle, the handle is already guaranteed to be unique if you always use a different name, which should be fine. And that handles the textual format too, because it's just the resource handle is guaranteed to be unique if you ensure it on distinct construction.
So I guess it's mostly a matter of ergonomic because the resources are printed always at the end of the module.
I mean, I guess actually thinking about it, technically you don't have to print them at all because resources like the IR, I think is, if I recall correctly, guaranteed to be able to print without them. So you don't technically need to print to print them at all. You could just, not do anything. And that would not do anything in the resource section, and you would just use the handles effectively.
Oh, so you have a distinct handle. Oh, that's even better. So
because
what would happen?
Can I put the handle somehow in another?
Yes, that's what I was thinking. Okay.
Yeah, that's how the dense resource elements attribute works. And it was made that way so that you could have IR that's valid without the data being there, which in this case, there is no data. So
if you go back to where you had those IDs 12012, I think we could exactly get this today by instead of distinct 0, right? Inside your alias domain, for example, you would also have I don't know how you want to call it, a domain or something like that.
ID or
an
whatever.
ID, and you point to a resource handle, and this is automatically handled by the printer exactly as you want today. And if there's no data, then don't think it's printing at the end. So the only thing we would have is like a name that is automatically renamed when there are collisions.
I mean, if this works, it sounds a bit weird because this is actually made for exactly the opposite, I would expect. So for a lot of data.
But not necessarily. I mean, it was made for out-of-band stuff, whether there's data or not.
But yeah, if there is a trick to not print this, that would be super, and just print the name or the alias or the handle, basically. Yeah, that would be.
So I think the only thing is that we need, I guess, I don't know, maybe we can use the blob one, but or we can have a built-in one. But because resources in general requires dialect support, but just for you know, a unique, sorry, a distinct ID. If anything is needed, the built-in dialect could likely host this.
Yeah, I mean, we could abstract stuff out realistically. Like, if the base stuff isn't useful.
Yeah. I
So
think
resource handle needs to be associated with a dialect immediately, right, River?
Yes, the dialect is the one that hosts the resources.
Right, so that would be printed always as built-in distinct something, right?
No. The handle is determined based on or like the handle itself knows the dialect. So it's like kind of automatically-ish. Actually, magically-ish handled. It's early for me, so I can't fully remember the details. But like the handle itself knows which dialect it's coordinated with because it's based on the type of the handle itself.
Yes, but yeah, exactly. But the type of the handle necessarily, it's an attribute, basically, a mechanism, and so the attribute needs to live in a dialect, and so it would have to be.
No, what I mean is the handle isn't an attribute. The handle is a struct. Like the handle isn't. It's not exactly like an attribute in that sense, the sense you're thinking of. So it
But
wouldn't print like built-in dot blah. It would just print like blah, basically.
How does it know that it has to go back to, when we pass it, how do we map back to a dialect?
The handle type itself knows which dialect that it's coordinated with. So it's like I'm a handle for a resource in the blah dialect, basically.
I'm missing a step. Something needs to be registered somewhere for parsing this.
Yes. So it's like if you know the handle is for the built-in dialect and you see a name for a resource, then you know to go to the built-in dialect to parse that handle, basically.
But how do you know in the first place that this is a handle for the built-in dialect?
It's built into the handle type itself. So you can think of the handle type as like a template type. It's like I'm a resource handle, angle bracket for the built-in dialect.
Yeah, but that needs to be printed somehow.
No, it doesn't. Because it's only on the C++ side that matters. And you know it when you're parsing it, that it's connected to that dialect. We can chat offline if you want me
Yeah, we're gonna have to take it offline. I'm reading the
to
code.
explain it to you.
I guess if I attempt to summarize, resources may be an option. I don't understand them well enough to really say that may work or may not work. And if it doesn't work, maybe having an attribute that is always print as an alias, and then use this alias printing mechanism for the numbering, maybe another option. Is that a fair summary, or?
Yeah, seems pretty close. I can help, I can post a proof of concept for the distinctness using resources if you want.
That would, of course, be super nice. If yeah, that would be super nice. I definitely will not have time next week to work on this, but afterwards, I think it's quite a high priority for us. So I will think afterwards I should have time to look into this.
Okay. I read the code now and I understand what you meant, River. All right.
Cool. cool.
Okay, it's a bit, there is some built-in support inside the parser, and I see what you mean. Dense resource is actually a keyword. So we could create just a distinct resource if we wanted something built in there, but that doesn't even seem necessary. Okay, I think we have 2 paths ahead at least that we can play with. So we are totally unblocked. Oh, we are much over time. I didn't even notice. We're 10 minutes over time. That was very productive, and we unblocked a lot of ideas in the last few minutes. So it's great. I think it was a good meeting. Thanks everyone for attending. See you next time. If you have any proposal of presentation or discussion, don't hesitate to contact me. Always a pleasure. Bye.
Thank you.
Thank you.
Bye-bye.